What is reverse engineering? Why do we need reverse engineering? Scopes and tasks of reverse engineering. Different approaches. Reverse engineering tools. And conclusion. What is reverse engineering? Let us first understand the concept of reverse engineering by doing a case study. So, you have just completed one course project using Java. Your program runs okay, but somehow unintentionally you delete that program file. Now, how would you get that file back and hand in your project? With the help of reverse engineering you can get back your deleted file again. As reverse engineering works backward from a chosen file to determine the design and technology used by the creator. Now let us understand in depth what is reverse engineering. Reverse engineering encompasses any activity that is done to determine how a product works, to learn the ideas and technology that were used in developing that product. Reverse engineering can be done at many levels. Reverse engineering generally belongs to software maintenance. You will get a better insight about reverse engineering by understanding the next model. Forward engineering. Requirements, designs, source code, and behavior. Whereas for reverse engineering it goes up from bottom. Behavior, source code, designs, and requirements. Let's see the waterfall model of software development. You might think, why do we need reverse engineering? Recovery of lost information. Providing proper system documentation. Assisting with maintenance. Identification of side effects and anomalies. Migration to another HW/SW platform. Facilitating software reuse. Now let us have a look at what are the difficulties in reverse engineering. Gap between problem or solution domain. Gap between concrete and abstract. Gap between coherency or disintegration. Gap between hierarchical or associational. Scope and task of reverse engineering. Redocumentation or document generation. Recovery of design approach and design details at any level of abstraction. Identifying reusable component and components that need restructuring. Recovering business rules. Understanding high-level system description. Discovery of abstraction in large system. Discovery of abstraction in large system. Maintenance purpose. Evolution purpose. Re-engineering purpose. Levels of abstraction. Application. Application concepts, business rule, policies. Function. Logical and functional specification, non-functional requirement. Structure. Data and control flow, dependency graphs. Structure and subsystem charts. Architectures. Implementation. Symbol tables, source text. Now let us understand different approaches. Restructuring transformation from one representation to another at the same level. Reverse engineering. Design recovery. Reproducing all the info for understanding the system redocumentation. Providing different views of the system re-engineering. First phase, understanding the system. Second phase, forward engineering. Reverse engineering tools. Analysis tools. Browsers. Object server. Task-oriented tools. Let's jump into the last part of the video, that is conclusion. Reverse engineering is a new research area among software maintenance. Reverse engineering includes activities of understanding the system and recovery information from system. Program understanding is the most important subset of reverse engineering. Discovery of abstraction is the key issue.
If you are new here, consider subscribing. Also, to learn more, hit the bell icon to never miss an update from MIDI Technology.